Hi Algebra 1, we're going to continue with our pre-geometry unit and learning the Pythagorean Theorem. You are going to go much further into the Pythagorean Theorem next year as a geometry student, but we thought that we would give you a preview of this topic just to make sure that when you walk into your geometry class, you're familiar with the theorem and you can use it for some basic problems. For these notes, you will need your calculator because we will be doing a lot of square roots that aren't perfect squares, and so you'll need your calculator for that. So you might want to pause it and get your calculator if you haven't done that. First of all, as far as the Pythagorean theorem goes, it only works for right triangles. And you'll notice here I have a right triangle, and I can tell that it's a right triangle because I see this little box, and that means that this angle is 90 degrees. The two sides that are connecting and meeting at the 90-degree angle, those are called legs. Okay, the A and the B. And then the longest side is the diagonal side, and that's called the hypotenuse. And a lot of times we call the two legs the A and the B, and then the hypotenuse we call length C. And then, of course, the Pythagorean theorem puts it all together and says a squared plus b squared equals c squared. And so let me show you one example for how you can use the Pythagorean theorem. You can actually use it to measure TV screens. So, for example, if they tell you that this TV is 20 inches, where are they measuring that? And actually, if you look at the screen, they're measuring from one diagonal corner to the other one, and they're measuring this length that connects those points. They are not measuring all the way out here to the actual corner of the whole thing, they're just measuring the screen. So they'll stop at these two corners. And for example, if I measured mine, it goes across 30 inches, and the width, the up and down part, is only 18 inches. And so if I call one of these my A and the other one B, I can find the diagonal C, and that'll tell me how big my TV is. And so if I take 18 squared plus 30 squared, I will get c squared. And so 18 squared is 324, 30 squared is 900, and now I can add those two things together. 324 plus 900 is 1,224, and that equals c squared. But that doesn't equal c yet. In order to find the value of c, I need to find the square root of 1,224. Now I'm going to get a decimal. I get c is about 34.9857, and so it's approximately 35 inches. And so if they were selling my TV, or when I bought it, they would have told me that this was a 35-inch TV. Let's just look at a few generic examples. Example number 2, I can see the legs are 4 and 3. I'm going to call one of them my A and the other one B. It really doesn't matter which one you call A and B. And this X, that's going to be our C. That's the hypotenuse. This is actually one of the more famous right triangles, this 3, 4, and you'll see what the hypotenuse is going to equal here in a moment. So we would take 3 squared plus 4 squared equals, you can call it C or call it X squared. 9 plus 16 equals X squared, and 9 plus 16 is 25. And then finally I can take the square root, and I get X equals 5. And so I have my missing value. And you can see from this triangle, the 4, the 3, and the 5 works out so nicely. And again, this is one of the more famous triangles. If you look at the next one, the hypotenuse, we actually know, 15.4. So I'll just go ahead and call one of these A, I'll call this one B, and then my hypotenuse, of course, is C. So 6.3 squared plus X squared equals 15.4 squared. So 6.3 squared is 39.69, and 15.4 squared is 237.16. So now, in order to find x squared, I need to subtract to get x by itself. Again, this is called the isolation process. So 237.16 minus 39.69 is 197.47. And again, if I take the square root of those, the square root of 197.47, the answer is about 14.1. And you can just double check with your triangle to make sure that the two legs are smaller than the hypotenuse, and they are. You can see on my next example I did not draw a triangle. The a is what's missing. So a squared plus square root of 6 squared equals 4 squared. Now you may remember from our square root unit that if you square a square root, they cancel each other out, and so we'll get 6 equals 16. Continue isolating, subtract, and we get 10. Find the square root of 10, and that'll be our final answer. And it's about 3.2. I should mention that when we isolated before in our quadratics unit, we always got a positive and a negative answer. That negative answer, if it was negative 3.2, that wouldn't make sense because we can't have a negative length. So I'm just ignoring the negative value of that answer. One more time. A and B, C would be 13. So 12 squared plus x squared equals 13 squared. That's 144. That's 169. Subtract 144. X squared equals 25. Take the square root, and x equals 5. And so that's our value for B. This is another famous triangle, the 12, 5, and 13, because the sides work out so nicely. Here's another word problem. A ladder is leaning against a building. So let's draw the building, and let's draw the ladder. The base of the ladder is 5 feet from the bottom of the building. So we'll call this 5. And the top of the ladder is 12 feet off the ground. So since this is the top of the ladder and this is the ground, this must be 12 feet. It says to draw the diagram, so we did that. And then part B, how long is the ladder? Well, that's what we don't know. So let's call this A and B. So A is 12. So 12 squared plus 5 squared equals x squared. 144 plus 25 equals x squared. That's 169. And again, if I take the square root, I get x equals 13. So we have a 13-foot ladder. If you notice, the problem we just did with the 12, the 5, and the 13 is the same triangle as we had up here. 12, 5, and 13 in example 5. And that's it for now. Have a good day.